I want to say welcome to everyone. I'm Martha Morgan. I'm the Water Programs Director at the Nashua River Watershed Association. And for those of you who don't know us, we are a member-supported organization based in Groton. And we have three main focus areas for our work, which are land protection, environmental education, and water resource protection in the 32 communities in Massachusetts and Nashua River, where our watershed lies. And so if you're not a member, we invite you to become a member. Just some housekeeping today. We ask you to mute yourself. The program is being recorded. And you can, I think Rebecca is okay with people interrupting if you have some questions as she goes along. Or you can type your question in the chat box and save it till the end and raise your hand or just unmute yourself and ask a question. So this is the sixth in a series of talks that we've had on rivers and fisheries. We've had talks on the removal of the Quinnipoxet Dam in West Boylston, the return of river herring, the importance of good water quality and mussel habitat. And if you missed some of these, you can see them on the Nashua River Watershed Association's YouTube channel. So I think you'll be able to find those and a lot of other really great videos that have been uploaded in the last year. We have some really great ones. So before starting, I want to acknowledge the Massachusetts Environmental Trust. They are the organization that, or foundation that supports this series of talks and also the work that we've been doing with Becca Quinones on installing temperature loggers in streams throughout our watersheds, the Coldwater fisheries that she'll be talking more about. So, and the way they get their funding is through the whale plates, the whale plate or the leaping brook trout, but these environmental license plates, and you can get those at whaleplate.org. And I told this story before, but my daughter was, when she was in graduate school, she was in Montana and she had a Massachusetts license plate, but she had a leaping brook trout. So I tell the fishers that she received instant credibility when she was driving around Montana and had that plate on the leaping brook trout. So that was cool, even though she was Massachusetts gal. So this evening's speaker is Rebecca Quinones. Dr. Becca Quinones is the Rivers and Streams Project Leader for the Division of Fisheries and Wildlife, or MassWildlife. Becca has a PhD in conservation ecology from the University of California at Davis, an MS in fish biology from Humboldt State University, and she got her start right here in New England with a bachelor's degree in wildlife and fish biology at the University of Vermont. So welcome, Becca. Thank you very much for coming and sharing your research with us. And I'll turn it over to you. I'll stop sharing and turn this over to you.
Well, thank you for having me. So as Martha said, my name is Rebecca Quinones. I have been with MassWildlife for about 5 years now, and I wear two hats working from them. One is as the River and Streams Project Leader, as she mentioned. The other is as a climate change specialist. And as such, I'm involved in a lot of the climate change work, regardless of the species or ecosystem that we're working in. If you are unfamiliar with the mission of MassWildlife, here's a quick summary. It is the conservation, including restoration, protection, and management of fish and wildlife resources for the benefit and enjoyment of the public. And really, to bring home the scope of the work that we do, I can talk briefly about some of the duties I had represented by these pictures. And so starting at the top left hand corner, I, as a project leader for Rivers and Streams, one of my authorities is to survey those streams and rivers that are not cold water. So you can think about the Nashua River in of itself, and some of the other rivers in the areas that, whether they're wadable or not, that are also of concern to us. We put a lot of emphasis on cold water, but there are certainly many river miles out there that are not cold water that are equally important to us. As we move around clockwise, this little square right here mentions the State Hazard Mitigation and Climate Adaptation Plan that was completed in 2018, and I spearheaded the division's vulnerability assessment, looking at all our assets and services that we provide and how we might expect climate change to affect them. Ultimately identifying 11 priority actions that we wanted to take to prepare the agency for climate change in the near and far future. I've also acted as the Sports Fishing Awards program coordinator, and that's represented by a picture here of our Youth Angler of the Year last year. She was very proud of all the species that she caught. Right now, I'm also working with a core team that's updating Biomap 2. It'll be called Biomap 3. I lead the aquatic components section of that, trying to update the data that's used and some of the methods that we're using to look at biodiversity from a more holistic place, not just looking at imperiled species. When I can get outside beyond surveys, I do help the districts and the hatcheries stock fish, both the trout that we raise ourselves in the hatcheries and also some of the pike that are coming from more southerly states. Right now, I'm also involved in a lot of the FERC relicensing. FERC is the Federal Energy Regulatory Commission that licenses all the hydropower companies in the state, and this is what this map is representing in the center. These are some of the hydroelectric dams on the Connecticut River. There's also another about 40 dams and hydroelectric companies that work in the state at any one time. 5 of them are going through some sort of licensing process that we're involved in. I'm also involved in habitat management and recommendations and the post-management monitoring. So this is a dam that came out of Hammond Brook. Hammond Brook is a tributary to the Quinnebog. And lastly, of course, I am involved in a lot of outreach efforts. So things like this where I give talks or I may participate in Riverfest. This is a picture from Riverfest in the Concord, near the Concord River a few years ago, where I was trying to turn on some young fish heads to the joys of knowing the fish in their local water bodies. So those are some examples of stuff that we do. Today, I do want to focus on some of the research that I've been doing, specifically kind of bringing those 2 lines of thinking of looking at the fishes in our streams and thinking about climate change. I'm going to touch very quickly on some of the climate change effects that we're seeing in Massachusetts as to provide a background to the work that we've been developing, and hopefully answering these next or addressing these next points of 1, why are refugia, this concept of refugia, what is it? Why is it important for climate adaptation? Then really specifically talking about identification of cold water climate change refugia, the work we've done so far, things that we want to develop into the future, specifically work that I want to do this summer. And ultimately, then how do we use those concepts and those findings to develop land protection and natural resource management recommendations? So very quickly talking about climate change effects in the state, these are the general trends that we're seeing. So we're seeing temperatures that are increasing across the state, not just average annual temperatures, but seasonally, these temperatures are increasing. On average, we're seeing about 1.5 degrees Celsius increase for the average annual temperatures, but we're seeing that seasonally, the winter temperatures are increasing much more markedly. That's about a 4-degree increase over time, which is disconcerting because that certainly affects how we're seeing precipitation falling across the land. And so that second bullet point, that's the rain to snow ratio that we're seeing on the landscape. We're seeing at about a 30% reduction in the March-April snowpack, which has huge implications of how we see flows in a river or streams. And what we're seeing is more extreme extremes, is kind of the quote that you might hear. When it comes to rivers, we're seeing flows that are peaking much higher and earlier in the season. So it's about a 2-week advancement into the spring that we would see prior to 1990. And on the flip side, we're also seeing more common droughts. So droughts that were common, say, every 5 to 8 years, we're now seeing every 2 to 3 years. And this picture was taken at the Neponset River in 2016. And it just depicts, if you see on the left there is the water staff that they were using to measure depth. And you can see the water edge is several feet away from it. So it's just depicting kind of those drought conditions that can happen fairly quickly and in a big way in some of the watersheds that we work in. In New England, we have a sense of urgency and of really curiosity for really integrating climate change into our management, because we seem to be experiencing, or we're documenting that we're experiencing climate change effects faster than in other parts of the world. And this is some work that came out of UMass and USGS and the Northeast Climate Adaptation Science Center in 2017. And how you read this graph is that they looked at multiple models to look at how quickly different parts of the world would reach a 2-degree increase. And so how you read this is that 80% of the models they looked at it predicted that a 2-degree increase in the global means would happen quite a few years, about 2060, quite a few years later than they would happen in the Northeast. And so they're estimating that in the northeastern states, that'll happen somewhere around 2040. So that's why we kind of have the I don't want to say the corner in the market, but we certainly want to be very actively thinking about these changes, not sitting on our laurels, so to speak. But we also know that these effects aren't going to be unilateral across the landscape, that there are going to be areas and habitats that are manifesting those effects faster than others. And it's these areas that are experiencing climate change at a slower pace. They will be impacted. That's not to say they're not going to be static. They're going to be changing, but they're going to be changing at a much slower pace. And these are the areas that we call climate change refugia. And so this is just a picture depicting on the left, kind of your typical, very intact Coldwater stream, and how perhaps it could change into something much more simplified on the right that has much more sediment due to the increased erosion that we may expect with changes in precipitation across the landscape. And so you have this dichotomy of or a gradient of effects that are going to be felt on the landscape, from areas that are going to be least altered and more resilient to change, and areas that may be very transformed and become these novel ecosystems. And so from a landscape perspective and management perspective, what's interesting to us is to really understand how those changes might affect the fishes or just the animals that live in these areas, right? I'm interested in fishes as an aquatic ecologist. And so this is just some pictures depicting that we might expect some areas where you have a very strong cold water community represented on the left by trout that may transition, that same area may transition to being more dominated by sunfishes or catfishes or suckers, species that can withstand warmer temperatures. So ultimately, one of the things that I wanted to answer was, well, can we identify these climate change refuges in the landscape in order to provide kind of an anchor, a cornerstone, kind of a pillar to where we start thinking about aquatic conservation? Kind of the thinking is that we would protect and manage the best of the best first, and then from there we can kind of think about the different areas that are being impacted differently. And so in 2016, this paper came out by the lead author was Toni Lynn Morelli. She's based out of UMass, Amherst also, and Northeast Adaptation Climates at the Climate Adaptation Science Center there. And she used in that paper that, with her co-authors, this example of different characteristics that make up a climate change refugia. And so I can see that my slide got rid of all the text that I had, but if you have a hard time reading this, they're just different characteristics along the landscape that a lot of you will be familiar, especially anglers are very familiar, that if you're, for instance, in a north-facing slope, that you're going to be in colder water, or if you're in a deep valley, in a canyon, the amount of shading that you get from the elevation around you provides colder water. Likewise, you can look for areas that have sources of cold water, either from snow that's depicted here or from groundwater inputs. In Massachusetts, we also have very deep lakes in some areas. These are the lakes that we call two-story lakes. They're deep enough so cold water can settle at the bottom and basically stratify. So you have two very different habitat types, that cold water in the bottom and water temperature up top. So that's also a refugia of sorts. And then also, you know, something that we think about a lot from our forest management is where do we see the thickest canopy to protect these areas and prevent additional solar radiation from reaching the streams. So, oh, here they are, they popped up. So again, those are just the landscape characteristics that we may look for that would signal then that these could be potential climate change refugia. And so in talking to Tony Lin, we started reaching out to other researchers. And certainly there is a rich history of research in Massachusetts and New England, and really throughout the range of brook trout, of folks thinking about the impacts of climate change to cold water systems. And this is just kind of the front page of this work that was done, spearheaded by Ben Letcher and Jeff Walker, where they looked at the entire range of brook trout from Maine all the way to Georgia. And they actually predicted what is the probability that brook trout will continue to be able to live in watersheds as you kind of run these models of warming. And they looked at three scenarios. One was at a 2 degrees Celsius increase, a 4 degrees Celsius increase, and a 6 degrees Celsius increase in average July temperatures. And so one of the very first things that we did is that we zoomed in on Massachusetts itself. And so if you go to this webpage, you can choose the parameters you look at. And so here we're looking at the occupancy probability of brook trout if there's just a 2 degree increase in July temperatures. And what is telling you that the lighter shades, watersheds are those areas that are most likely to continue to support cold water habitat into the future with just this little bit of a temperature increase. Now, that doesn't mean that brook trout won't be present in these darker areas. It's just that the likelihood that they can survive throughout the entirety of the watershed is lessened. It's harder. And if you really think about the landscape in Massachusetts, you can think about how these lighter areas are closely tied to not only elevation, but forest, how intact the watersheds are as far as forest cover that they have. But the kind of challenge is that those watersheds are really large areas. And so when you're trying to think about specific management actions that you want to take, you know, we think of management actions taking at a kind of place in a site level. And so what I ended up doing is to try to get to a kind of more localized a view of where we can do our actions is to then tie that same map that I just showed you about at the watershed scale to our fisheries database. And so what you're looking at here is a map of Massachusetts, and all the dots represent surveys that have been done since 2000 by the fisheries section at MassWildlife, and the different colors represent the type of survey that it was. So if it's purple, it was a survey that was done in lakes and ponds. If it's red, it's a survey that was done at a warm water river or stream. If it's blue, it was done in a cold water stream or river. And if it's black, it was a place where we just didn't find fish during the time of survey. Doesn't mean the fish were never there. It's just when we surveyed, they weren't there. And so the kind of the baseline hypothesis was, well, if we just look at these blue dots, then these are areas that are already providing cold water. And so essentially, these are potential climate change refugia. These are areas where we already have the presence of at least one of the 11 cold water species that we find in Massachusetts. And that's 11 cold water fish species. There are others that we might consider things like spring salamander or some of the dragonflies that depend on cold water that are not included here, but that certainly would be providing some additional information on what could be important. And so I ran the same models that was done at the watershed to look at how many of these dots, these sites that we have data for, will become too warm, are expected to become too warm in looking at these different scenarios. And so we can see as I basically just run that model, that same model that the folks had already developed, you can see that some of these sites are likely to become too warm in summer to support brook trout under a 2-degree increase, and that's about a 42% loss in the sites. If I run it again and look at a 4-degree increase, it's an additional 28% loss. And ultimately, when you look at the highest kind of warming scenario of 6 degrees, we lose an additional 45% of those dots. And from now to when we might feel that 6-degree increase, it's about an 80% loss in sites, which is really disconcerting when you're trying to think about what kind of management actions you want to, protect these areas. You want to make these areas more resilient as much as you can through either land management or in-stream manipulations. And if you want more information on that particular side of the research, that's something that we published just last summer. And this is just showing the kind of the header of that article. It is an open access article, which means you don't have to pay to get it. And it's interesting because while Ben and I used the Massachusetts example to look at specific issues here, Joseph, and Sean, who were co-authors, looked in Oregon. And it's fascinating to see how very different landscapes have very similar issues they're dealing with, whether it's dams or water withdrawal. And it's interesting to see how they're approaching the same issues. Okay, so now I have a map of these potential cold water areas. I know some of them are going to warm faster than others, meaning that some of them are going to be more resilient. Those areas are going to stay colder for longer. And so what becomes very evident is that there is no one size fits all as far as land management practices that would protect them, or as far as establishing aquatic conservation actions. And so one of the very first things that we need to do when we're looking at models is we need to validate that model. We have to build some sort of certainty and assurance that what we're looking at reflects reality. And so in 2019, I started placing temperature loggers into these sites that we identified and doing fish surveys again. One, to answer very basic questions like, are they still functioning as cold water habitat? And so that is ultimately what we did. And for, I would say 99.9% of the sites that we went to, they are still continuing to function as cold water habitat. We have loggers in place over the longer term in different watersheds in Massachusetts. The Manhan River was one that I had loggers in starting 2019 and ended up pulling those out. That was work that I was doing some volunteers there. And the issue there is that the geology of that watershed is so sandy that our loggers were getting buried. And so you end up getting really good temperatures of hypereic flow. That's the flow of water that is subsurface, that's flowing through the sediments, rather than the water that is up in the water column that the fish are exposed to. So we ended up pulling the loggers in the Manhan. We still do have loggers in the Blackstone River. That's mostly in the Emerson Brook watershed, but we also have places like Bacon Brook and Cold Springs Brook. And then this longer term study started in the Squannacook River, working with the TU folks, working with Martha and her colleagues in RWA, where we started with just 9 loggers throughout kind of the Townsend and upstream areas of the Squannacook, so places like Pearl Hill, Willard Brook, Lock Brook, Trout Fall, some of the areas that we looked at. And just this last year, NRWA also added additional sites. Martha, how many sites did you guys end up adding last year?
We installed 14 loggers.
14.
The Squannatisset chapter of Trout Unlimited have 9. We did, and they helped us with a lot of these also. They were in, areas where we thought there might be seeps and cold water at Refugia. So.
Perfect. Yeah, so it ties perfectly into this work. And just recently, I was approached with folks from Friends of the Ware River, where they also have some loggers that are going out. But this is great data because it really grounds the temperature modeling that was used to look at occupancy on data itself. So the more data we feed into the model, the better chances we have that we're reflecting reality and can put some weight into the results that we get. I also want to mention that I do have one more partner up in New Hampshire working with the Amonoosuc River TU folks and the Department of Fish and Game there. Diane Timmons has been helping me. Unfortunately, I haven't been able to travel there because of COVID, but those loggers are still up and running. And what's interesting is that that gives us a regional perspective. There's this thinking that some organisms will be able to migrate northward or upslope in order to continue to experience that colder climate that they need, whether it's cold water or colder forest. And so one of the very basic questions that we might have is, well, how intact is that habitat going to be? Even if the fish could get through all of the barriers that they would need to in order to migrate northward, once they're there, what is the quality of the habitat and whether that habitat in of itself will be shrinking over time? And so that's giving us a little bit of a perspective at a larger scale that we're doing here in the state. So something that I want to make sure that we understand is when there's refuges and then there's refugia, and I apologize because scientists do this all the time, using very similar words to mean different things. And so when we're placing temperature loggers in a water seep, we're thinking about measuring refuges. And so that's represented here in these little ovals. Can you see my pointer when I move that?
Yes, we can.
Okay.
Yep.
So the seeps, you can think of the seeps as these kind of very localized cold water patches. And then in concert, they function as a refugia. And so a refugia is a network of refuges that support a population of fishes or whatever it is that you're interested in. And so this diagram is just depicting that in a river network represented by the blue lines, you may have a main stem and some tributaries and some headwater streams, that there are going to be refuges throughout the life history of an organism that become important. So in summer, you may have cold water fishes that need this cold water refugia. But you may also need protection from flows, like areas where you know that are gonna be perennial, regardless of drought conditions. There's gonna be flow, there's gonna be water there, there's gonna be habitat. And so there are different types of refugia that need to work in concert with one another in order to support these, not just individuals, but population levels, numbers of individuals. And so it becomes really increasingly important to think about connectivity between these sites in order to understand how they function together. And here I'm just reminding us that in New England and in Massachusetts, we have a lot of dams represented in this diagram by these kind of black rectangles. And so thinking about not only how fish are moving, but what are the barriers to their movement becomes important when we're trying to think about not just persistence over time and how they will deal with climate change, but also the land management actions that we might take. And while we talk a lot about dams, there are other issues that we're dealing with. So this is a site that I was monitoring with the Blackstone River Watershed Association on Skadden Brook, where we had a temperature logger that's here on the right-hand photograph. And it's just reached over and completely dry. And so while we think of hard structures and barriers, this is certainly a barrier, an area that goes dry. And this wasn't even in a headwater stream that you might think of contracting as things get drier. This was kind of in the middle of the stream. And so it was really interesting to see how fragmented this particular stream became over time, and a concern because, you know, if you're lucky enough to be a fish that can move out of there, you might find other habitat, but if you become stranded, then you're that's it. That's kind of the end of the road for you. So just want to remind us that while we're talking about just temperature in this regard, climate change, of course, is going to be changing the hydrology. I mentioned that before. And so we often can think about just the extremes where there's the peak flows when they're happening and kind of the magnitude and duration of the peak flows. Likewise with droughts, it's interesting to look at the entirety of the hydrograph. Hydrograph kind of depicts the level of flows over time in a given point or stream. This is the Squannacook. I think this was from last year. Let's see what my jag. And so while I'm not dealing with this explicitly in the study, this is something that we're definitely keeping in the back of our heads, that it's something that we need to investigate further. So now that I have this map of Refugia and I'm starting to understand how they are working together, or the refuges are working together to give us Refugia, we need more specific data. So one of the things that I wanted to do this summer is to start thinking about what are the characteristics of Refugia, specifically in some of the sites that we're monitoring. So things like, how many refuges make up a refugia, and how far apart do they need to be, and what size, how much volume of water? You can start stacking the questions up, right? So you might think about how much cover does it need? What is the temperature gradient from ambient to the coldest spot in that refuge that you need in order to think about populations? In my mind, this is a question of, what is the carrying capacity of a stream in the summer? The carrying capacity is essentially how many fish can a stream support during the warmest part of the year, because that may be what's limiting the future populations there, right? If the rest of your fish are dying because they can't find that cold water that they need, then really what you're talking about is not the entirety of the population, it's just those few that can find the cold water to over summer. It's a question that we're exploring. And the way that we want to do that is through a collaboration with USGS. Matt O'Donnell and I have been developing this project as recently as just last week, where we are going to join forces and do some thermal imaging that is essentially mapping the temperatures in a stream, and then pit tagging fish in the stream itself to see what are the areas that they're using. Also, a fragment of those that have pit tags in them will have thermal tags, will measure their internal temperature. And so ideally, once we map what the thermal landscape looks like, and so this is an example, different scale, this is the Fraser River in British Columbia, but you can have FLIR cameras where you can actually map kind of these colder versus warmer areas. And then on top of that, then with the pit tags, you can see where fish are located as you're moving through a system. So we would have to do this several times throughout the summer, multiple times, because of course these areas will expand and contract not only during the day, things get warmer in the early afternoon and cool off in the evening, but also seasonally. So in the beginning of the season in June, you may have very different conditions that you may have in September. And so once we have this kind of imaging that we'll do and repeatedly throughout the season, we can tag our fish with these little pit tags and then use a wand to actually read out that tag and locate the fish in the stream that we're monitoring, which will be fascinating. And I'm really looking forward to doing that. In the National River, one of the areas I'm looking at very closely for this type of monitoring is kind of these habitats associated with Pearl Hill Brook and Willard Brook. And these are areas that I chose specifically because we've had temperature loggers in them for a few years now, or going on a few years now. So I have kind of that baseline data over the entirety of the stream. And then now with the additional thermal imaging and the pit tagging and the thermal tagging, then I'll be able to look kind of at a smaller scale, kind of the microhabitat scale, to piece together all of those refuges that are working together to provide refugia. And ultimately, it is the recommendations that we would use, for instance, to think about how do we buffer refuges or cold water patches? Like, what is the scale? Like, do we protect just the immediate patch, or is it really has to be 2 or 3 kilometers of patches together in order to protect populations in a particular watershed? So that's kind of where we're heading. I did have, it's you folks that are very familiar with the area, do we know if Pearl Hill Brook Pond is a natural pond? Just right here. Anyone know the answer to that?
I think it has a dam on it, but I'm not positive.
Because that to me is a prime location for some restoration, but we can talk about that.
It has a dam.
It does.
I thought it had a dam, yeah.
Okay, so I'm gonna back out again. This is the same information I showed before when we zoomed in on Massachusetts and we were talking about resiliency in colder watersheds. It's just a different color scheme. And so in this case, kind of the areas that we think of more resilient and staying colder for longer are in blue, and then kind of the more yellow areas are areas that are likely to warm over time. And so the reason I bring this up is because then I can use kind of the more specific site data that we're collecting, whether it's for Coldwater through the thermal refugia or climate change refugia work that we're doing, or if we can also look at warm water systems. This is just a map that I put up and the natural river, because we've been doing this across the state where we're looking at native species richness. So I just wanted to mention again that although we focus a lot on Coldwater, we have these amazing, really intact, warmer water systems that we need to think about. And so it just happens that the main stem has a lot of warm water species in them that are worth protecting also. And so you can bring those two concepts together, that of resiliency and refugial areas, and whether it's the location of a cold water species or location where you have high native species richness, and then start to think about what are the resource management that makes sense at each location. And so these are some examples that I put together. So if you're thinking about strictly land protection as a management action, so you're not necessarily going in and restoring anything, you're just protecting the land that things are found in or the type of habitat that you're interested in. These might be areas where you have high resiliency. These are areas, what I mean by that is that they're likely to change very little over time because of climate change, but also have high biodiversity, whether it's cold water species or the entire native species assemblage. So in those cases, you might consider doing land protection, right? That's basically protecting the best of the best. Whereas if you're looking at areas that are high resiliency, so again, areas that are not likely to change much into the future, but have medium biodiversity, they're slightly less, then you might look in the stream channel itself to understand what's causing that. Is it, for instance, an area that is fragmented by a dam, and it would make sense to remove the dam in order to provide more mixing of upstream and downstream assemblages? You'd have to do some investigation to really get down to it, but it suggests that it may be a different action than just land protection. Likewise, if you have an area that has medium resiliency, so it's going to change a little bit more over time, but has very high biodiversity, you might also consider doing some management there. And in that case, it may be like restoration at a watershed scale, and maybe like riparian planting, for instance. And so we can start bringing these concepts together to really feed how we manage resources. And in fact, this is a framework that we're currently developing for Biomap 3 as we move forward. And so I just want to end. That was a ton of information. I try to give you some snippets off in a fairly short amount of time. And I want to make sure that I recognize that there are a lot of people that are working with us on this. It's not by any means work that we're doing in a vacuum. And so I just absolutely have to acknowledge their efforts because they're instrumental in us getting our work done. And with that, I'll end. Any questions? I didn't see any raised hands as I went along, but was there anything else that folks want to explore or talk about?
Yeah, thank you very much, Rebecca. That was great. So I just want to mention something that when we sent out our notice that this talk was happening, I think we said the state of Massachusetts identified cold water fish resource streams, and it's actually MassWildlife who did all that work. It's a lot of work. And some of the most rich areas of these cold water fish resources kind of begin right about at the Nashua River area, as you're moving west from like the Boston area. So just wanted to point that out.
Yeah, it really is, it really jumps out at you as far as that type of habitat and the importance of it in the eastern part of the state.
Right. I have a question. So I'm going to jump in here because I'm going to forget it if I don't ask it. A lot of these areas where you're identifying the refugia, like Willard Brook, are also threatened by the woolly adelgid and the hemlock decline. And I'm just wondering, how will that affect your models, going forward?
Yeah, the models itself just looks like canopy cover overall, and not necessarily, and it is associated with landscape cover. I believe it's a 2016 is the latest one that was looked at. So moving forward, that may change, right? As they run the models periodically, and so that may change not only because the canopy cover may change, but the composition may change, and so the way that the habitat is thermally protected might change. For instance, if we have deciduous species moving in and replacing hemlock, that may be very different. So yes, you will fully expect them to be impacted and change that model somewhat. We just may not see those results for a little bit. There's a bit of a time lag, right, into getting those effects.
Right, okay. Thank you. So we have a question here. You mentioned about canopy as potentially something that helps creates refugia. What is being done to reduce the loss of canopy with new housing development in rural areas?
Yeah. Yeah, so I mean, I can't stress this enough that the Concoms have an incredible power to help us protect those areas at the town level. Also, you know, any of I'm really at the edge of my knowledge here, so help me out. But the town bylaws can dictate how much development happens, the type of development happens. Something that I see a lot of that has concerned me over the 5 years that I've been here is the lack of enforcement of encroachment. And so even when you have those bylaws and you have the Wetlands Protection Act that is protecting riverfront property, riverfront area, you still have a lot of folks who want to see the river there nearby. And so they're cutting into that riparian forest, which is unfortunate because that is really one of the most immediate and directly felt protective measures that we can have that is largely self-sustaining. So I advocate for folks to get involved in you know the development plans in their towns and really be voices for protection of those areas.
Thank you. I'll just say if people want to either raise their hand or just unmute themselves if they have a question or comment. Rebecca? Marion.
Yeah, right. So I'm just really interested in what you just said, Rebecca. And I just saw that the Merrimack River Watershed Council has gotten, I believe, a grant from the U.S. Forest Service to plant, I forget how many thousands of trees along the river. And so I'm interested to know whether this is a program that might be extended into the Nashua River watershed.
I don't know much about that particular project. The Merrimack to me is near and dear to my heart because it is incredibly high in diversity, right, for native species and in endangered species, and yet it's probably one of our most hammered streams or rivers. The issues there not only are so. From riparian forests, the impact from protection to prevent solar radiation coming into the stream is lessened the bigger the stream is, right? Because the proportion of the water that is away from the vegetation is larger in larger systems, right? So you're going to have more radiation coming in regardless. But there are other benefits like the inputs of large wood, there's habitat for bald eagles, there is any number stabilization of stream banks, regardless. So when we talk about climate change refugia and associated with canopy cover, we're usually talking about smaller size streams. That's not to dishearten anybody from doing any work in the Merrimack, because I hope that they continue to do that. But that's kind of the context that we talk about when we're thinking about climate change refugia, is kind of these areas where you can have a lot of overhanging vegetation that is essentially covering the streams or a large portion of the streams.
Right, and we did, Marion, the Nashua River Watershed Association did have a project a few years ago with the Merrimack, doing plantings along streams in the Nashua.
I remember that.
Al
Yes.
Fetterman was doing that, yeah.
Right. So I think it really brings out the importance of the completion of the Greenway along the Nashua and its tributaries. Shade.
Right, right. Thank you, Marion. Anybody else? Questions? Comments? It's fascinating.
Hey, Master David, I have a question. Hey.
Oh.
Oops. Sorry, David, we can't hear you. Can you unmute yourself again? Sorry, I might have done that by accident.
Okay, so my question is, how long you want to keep your loggers out there in the river?
Good question.
Yeah, I mean, I'm keeping them as long as the battery life happens, right? So David, I assume you're the David that works for DEP, right?
Yes,
so
right.
I've seen a lot of your data sets, and they tend to be shorter. You're measuring kind of a shorter time span associated with, I assume, infrastructure or specific projects. I'm trying to look at kind of that long trend, right, as long as I can. And so I suspect that a lot of the loggers that went in 2019 are probably towards the end of their life, and I'll need to be thinking about replacing them.
I know the ones that we installed, we were hoping to keep them in for 5 years, and we're not sure how long the batteries are going to last. So that they're different. They're Bluetooth operated, whereas Rebecca's are they get downloaded by a shuttle, so it's a little bit different. So we have another comment. Living in an area where we are on the backside of a hill that protects temperature increases. I understand what you mean by protecting those areas. Is there anything being done to protect these? In our case, our spring is at least a week or two later than neighbors. If you want to.
Yeah, I mean, if you're in a kind of protected area, that the other really key piece, especially if you have any sort of elevation, is to make sure that you have enough ground cover to protect the soils from erosion. So those are the other things that we think about, particularly in hill slopes. I don't know what your particular area is, but it is just another characteristic of these kind of small water patches that collectively are going to be really important into the future. And so I encourage you to protect kind of the ground cover around the spring itself, but also upslope of those areas.
Okay. I think he's replying, yes, we have nice woodland. It would be good to protect these areas. And so from Anne, it would seem that aquatic insects would be centennials. Are you tracking them?
Yeah, so me not personally. So that's done by Jason Carmignani, has been looking at them. And then DEP does their aquatic microinvertebrates, and we have looked at them. David, something that we've been really curious about, and I don't know who at DEP might be able to help us, is that to think about collecting that information in a more systematic way. I see that there's a lot of index sites, but to think about them across the landscape, I wonder if there's a way to use that data in some way, and it may not meet your needs, but maybe we can join efforts in order to get that information. It's certainly something that's done in other states. Connecticut, and particularly New Hampshire, has a really active program looking at macroinvertebrates and aquatic insects to look at water quality.
Yes, Rebecca, that's a very good point. Right now, DEP is contracting with the Tetra Tech to develop the biological condition criteria, like a gradient model to, try to figure out, what's the best station for those macroinvertebrates. So that's a very good point. If you know, you and DEP, we can collaborate together, that's going to be more valuable, especially.
That'd be fantastic.
Yes, especially like the 5 stations in the northwest of Massachusetts. The long-term data start from 2012, so it's not almost 10 years, 9 years now. So yes, that's why I'm curious how long you want to keep your logos. The longer the data, the more value it's going to provide to us, you know.
Exactly.
Yeah,
but
very
as
good
you well
point.
know, sometimes we're challenged to in budgets and manpower. So we're doing the best we can, but that is the idea, that we have kind of these longer data sets that kind of straddle different types of habitats. I'm especially curious about Coldwater habitats. That's kind of the next type of habitat that's slightly warmer than Coldwater, but straddles that warm water and Coldwater, and maybe even rarer than Coldwater because it is kind of more transient. But yes, so establishing some index sites, but also enough random sites in order to be able to draw conclusions across a variety of landscapes would be fantastic.
Yeah, absolutely. Yeah.
Thank you. A couple more comments from Ann Harris. Anecdotally, the insects are less common. Hatches are definitely off.
Yeah.
And she said, are you looking at catch reports from fishers?
We haven't, and that will be really fascinating. There's some studies coming out of Switzerland, out of all places, and Austria, and places along the Alps that are documenting stoneflies coming out, you know, months ahead of time because of warming, and how that affects kind of the entire trophic biology and the prey base for subsequent species, including fishes. And how that affects growth rates and survival and their ability to complete their life cycle. So we ourselves are not tracking that. That sounds like a really fantastic citizen science project. If that's something that needs to be tracked, but changes in phenology, that is changes in the timing and of life cycles of organisms, including insects, would be very telling.
Thank you. Yeah, good point.
Yes, I'll recruit to you.
Right.
I have a question. I guess I asked the question to Rebecca, so it did not get recorded. Do we have accurate data as to what has been the change in the average temperature of cold streams in Massachusetts over the last 10 or 20 years? Being an engineer, I like to see, you know,
the actual data,
what the level of the problem is, and what is happening.
So I'm trying to think, you know, we don't have it across the entire landscape. I'm thinking of, again, it would reach out to our collaborators at UMass and the Forest Service and USGS. They've been looking at Westbrook in the western part of the state for decades. And so there are examples where temperatures have been tracked for, 20, 30, going on to 40 years, but it's definitely not across the entirety of the landscape.
I see. Well, it'll be interesting now that you are increasing the efforts in that area to plot the average change over time. It will give us a much better picture of what the size of the problem is and so on.
Absolutely, yeah. And I would expect that systems in the western part of the state would behave very differently, as we've seen in the models, to say like the southeastern side, just strictly because of elevation and because of forest type. And the input from aquifers will be really important in groundwater, other groundwater inputs.
Thank you.
I'd like to ask a question, please.
Sure, go ahead. I just so you know, I have my computer has frozen. This is Martha Morgan. So I'm on my phone now. So this has happened before to me. But go ahead, ask your question.
Thank you. You mentioned the presence of man-made obstructions like dams raise the temperature. What happens when you remove those? It seems to me you you could lower the temperature, but you'd also perhaps suffer other effects from where you remove the water. Could you just expand that a little bit?
Yeah, absolutely. There's a lot of literature associated with dam removals across the U.S. and other parts of the world. But specifically in Massachusetts, we have a collaboration with a USGS. Again, this is with the Co-op Fisheries Unit and Fish and Wildlife Unit at UMass. And Kate Abbott is doing her PhD work looking specifically at the changes that we expect to happen after a dam removal, not only looking at temperature, but also looking at other parameters, including the trophic structure of macroinvertebrates, looking at those aquatic insects, trying to tie it into the assemblages of fishes that you would expect. So we'll have better answers. Conceptually, we have a very good idea that yes, once you remove a dam, depending on the size of the reservoir behind it, that you will have a lowering of temperatures. And we see that when the dams are left in, that effect of warmer temperatures, it goes downstream quite a distance. And that's really her work and Alison Roy's work coming out of her lab, looking at that. The monitoring that has been done, for instance, in Hammond Brook, which I mentioned in the talk, does show that temperatures are impacted, perhaps not as much there because of the size of the system. And again, the size of the reservoir and probably some groundwater inputs. So it's not as simple as lowering temperatures kind of as a straight line, but it may be defined by the characteristics of the site itself. But in general, removing a dam has so many other benefits beyond just temperatures. You have improvements in, for instance, the oxygen, amount of oxygenation in the water. You have benefits to the sediment supply, to downstream habitats. Certainly you have that connectivity that allows the migration of fishes both up and downstream. So from a cost benefit analysis, dam removal is often one of those things that just remarkably changes the quality, improving the quality of the habitat once it's completed, the dam removal.
Thank you very much.
Thank you. I have a couple comments here. Thanks for a great talk, Dr. Quinones. And from Ann Harris again, are you looking at temperatures along streams up and down, up versus downstream? And for example, have temperature gradients changed?
Yeah. Yeah, and so for instance, the loggers that we have in the Squanicook watershed, almost all of them, I'm trying to think if there's anyone that we are not, they're paired. And so we have, for instance, sites in Lockbrook that are in the upper parts of Lockbrook, and then we have one that's kind of towards the main road, and forgive me, I forget the road now. But same with Pearl Hill and Trap Fall. It'd be wonderful to have more than just two, but we do have differences between upstream and downstream, often because of the amount of water, and particularly when we have those more droughty years, that lowering of the water level in the downstream end really affects how the temperatures are read by the loggers.
It was heartening for me last year to see that a lot of the loggers were still in the water even during the low flow. So they were chosen well by the TU folks that put those in. And then when we put ours in, of course, it was low flow also. So hopefully, they will stay in the water. But so it's 8:02. If there's, maybe one more question, we can take one more question or comment. Other than that, well, I think just say thank you very much to you for a great talk. And I look forward to you coming back and giving us an update in a couple of years. So
thank you very much. And if anyone needs to reach me, you can reach me at my email. It's just my name, rebecca.quinones@mass.gov.
Thank you. And I guess we'll say good night.